Ladies and gentlemen, we now have an expert speak. The topic is at the intersection of AI and psychology. AI is the most promising technology which enables machines to perform human-like functions accurately and efficiently. As we develop these emerging technologies, we must ask ourselves, how will societies interact with them? That's where psychologists come in, because we are very good at understanding people's behaviors, motivations, and perceptual and capabilities and limitations. Despite being two seemingly related fields, psychology and artificial intelligence developments have occurred in parallel. So let's hear from the great psychologist about the gaps and intersection in AI and psychology. Our speaker this evening is JT Kostman, Chief Executive Officer, ProtectedBy.AI. Dr. JT Kostman is a data scientist, mathematician, psychologist, and one of the world's leading experts in applied artificial intelligence and cognitive computing. JT has hunted terrorists for the US intelligence agencies, tracked criminal networks for the FBI, advised on analytics strategies for the Department of Defense, and led social media analysis for the 2012 Obama campaign. It's a pleasure and honor to have JT here with us. Over to you.
Thank you, Justin. And thanks to all of you for being here. I've been looking forward to this event for some time. I was thinking about it this morning, and the first time I joined NASSCOM was, I think, about 10 years ago. And I also have the privilege and the distinction of having been one of the first virtual speakers. And now that's sort of become the norm. So this is exciting times. It's great to be with all of you. It's always great to be in India, even if it's only virtually. You've read the introduction, you know who I am, so I'm not going to bore you with that. In fact, many of you I know have worked with me or worked for me over the years. And so, hi, gang. It's good to see you again. I am here basically to share some thoughts with you as you wrap up what I know was a very exciting event. You learned a lot. You've met some interesting people, I hope. And you're taking some things away. Before you leave, before you go home, I had some things I wanted you to be able to think about. And so the conference organizers asked me to come in and talk a little bit about my work and my perspective as an AI psychologist and how that might be able to help you in your future endeavors. We are living in, I don't have to tell you, some extraordinarily interesting times. I have had the great privilege of working with some extraordinary teams in the US, in India, and most recently, even in South Africa, where we're working with the South African government to help battle fraud, waste, abuse, corruption, and theft, and ensure the equitable distribution of resources to traditionally disadvantaged populations. And I bring that one up in particular, that project up in particular, because my career, my work has largely been about trying to bring AI, bring technology to affect a social good, to do something positive in the world. And I know all of you who are listening today have that same mindset. How can you do two things? How can you do well for yourselves, quite frankly, while doing some good? How do you sort of future-proof your careers and make sure that you're playing a vital role in some really interesting areas and doing some cool work? Well, I happen to be currently the president, the CEO of a company called ProtectedBy.AI, where we do a lot of that work. But I also, in sort of my evening job, my moonlighting job, I'm the host of a new podcast called Tomorrow Today. And I'm going to encourage all of you, here's the QR code. I'm going to encourage you to join the conversation, to listen in, to participate and to hear some of what we talk about to be able to better help, frankly, us, the members of our tribe, be able to get the skills, the mindset, the perspective they need to succeed, to prepare themselves for tomorrow today. And so I'm going to encourage you to tune into the show, because tomorrow is going to be, we all know, very different. We're on the cusp of some extraordinary changes. And these are things that are impacting not just the US, not even just India, but globally. The world is changing, and it's changing at a pace that we've never seen before. We're seeing those changes, I think, start from and come from one area in particular, and that's what we do. It is coding, it is programming, it is more specifically the areas of artificial intelligence, machine learning, robotics. the areas that are near and dear to most of our hearts, those of you who are attending this conference. And this is nothing new, right? We've been talking about thinking machines, and we've been talking about getting computers to be able to emulate human beings since, well, of course, since that brilliant mind Turing first wrote his paper, Computing Machinery and Intelligence. But even before that, if you go back, and I did a little bit of checking, the first mentions I could find about starting to think about these topics come from a novel called Erewhon by Samuel Butler, written in 1872. And in his Book of the Machines, which was a book within the book, he talked about artificial consciousness, which we know is artificial intelligence, and self-replicating machines. Remember that term. We're going to come back to that today. Self-replicating machines. For me, the journey began a little fast forward. It began with reading Isaac Asimov's wonderful series, Foundation. And in Foundation, Asimov had a protagonist, had a hero, had a main character by the name of Harry Raven Selden. And Harry Raven Selden, was a psychohistorian who specialized in the mathematical analysis of social structures. Well, that, believe it or not, actually set the course of my life. By training, I am a data scientist, a mathematician, and a psychologist. My first PhD is in psychology, and I went and I did my postdoctoral work all in mathematics for the express purpose of being able to quantifiably understand human nature and how humans act. And not just understand it, but to understand, predict, and even influence human behaviors. And that's what AI psychology in large part is about, although there's a bit more to it, and I'll talk to you about that today. But my journey actually began in reading these series of books and then finding my way to the keyboard. The keyboard back then was a little different than it is now. This is the machine I actually learned on. This is an IBM 1620, and we had to code it, believe it or not, using Hollerith punch cards. This is quite the heavy-duty machine. I still have the manual for it on my shelf somewhere. It won't surprise you when you see how much stuff is on my shelves. And I was looking at it the other day, and it said the capacity of this machine was it could hold a whopping 60,000 digits, which I think you can fit into one cell in Excel now. And it operated at 0.007 MB. That's the only James Bond thing about this machine, I assure you. But this is sort of the beginning of my journey, but it wasn't the beginning of the journey in AI. The beginning of the journey in AI began in earnest, I think we can all agree, here at Dartmouth University in New Hampshire. And it was there in the summer of 1955 that a group of extraordinary people came together to define AI. And it was the first time they actually used the term artificial intelligence. And it was people like Claude Shannon and McCarthy and Minsky and Rochester. There's just these extraordinary people who came up and they said in their proposal for this conference, and you'll see I have it kept here on the screen, we propose that at 2 months, 10 people studying AI should be carried out during the next summer at Dartmouth College in Hanover, New Hampshire. They say, and I'm quoting here, you can see on the screen, the study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstraction, and concepts, solve kinds of problems now reserved for humans, and improve themselves. We think that significant advances can be made in one or more of these problems if a carefully selected group of scientists work on it together for a summer. So in short, what they were saying was if we got together with 10, 15, 20 smart people, we could crack AI within the summer of 1956. Well, they came up a couple of years shy. It took a little longer than that. But I think we're there now. I think we've come to a point where we have figured out at least a set of tools. We've reached a plateau with the development of machine learning, deep learning, robotics, with some of the work that's been done over the last 10 years, even 5 years, even 3 years, even over the last year. We've come to a bit of a plateau, not where I don't think there will be continued acceleration and continued invention, but a place where we can start to move from the age of innovation to the age of implementation. And what do I mean by that? This, to me, is reminiscent of the times of nothing so much as the years after Gutenberg invented the printing press, and what were we able to do and capitalize on from that when Edison invented the light bulb and basically unleashed electricity into the world. The age when the computer was made personal, right? Whether it was by Gates and Allen or the Steves, Wozniak and Jobs. And this started not just a culmination of work. This actually started a new way of thinking, a new set of tools that we could use, and we could use very effectively to be able to advance us to the next level. Likewise, we're seeing the same thing in AI with the contributions of people like Hinton, LeCun, and Bengio, and gosh, name countless other scientists who've contributed. I like to think my groups have contributed in some small way, at least. We're seeing that we are starting to finally even bridge that sort of carbon silicon divide. We're coming to a point where machines aren't just being used by human beings, where we're working integratively with human beings, and we're working together seamlessly to be able to accomplish our agenda. This is something that we have, in some ways, it's innovative, it's new, it's exciting for us, but it's also very familiar to us. This is what technology has always done. I offer to the people who are always afraid of the rise of the robots and that AIs will take over and run our lives. We as a species have always been interdependent and reliant on technology. Whether you're talking about eyeglasses or earbuds, or you're talking about pencil and paper, whatever technology you choose, the objective technology has always been basically to make human life better. Right? It's been to alleviate us of the dreary, of the dangerous, and of the dreadful. We build technologies so humans don't have to do these things, and so that we can work seamlessly, integratively with the technologies to be able to do that. Well, how do we do that most effectively now in the age of AI? It's a little bit different than it was. When Edison invented the light bulb and we had and he unleashed electricity, we had a bunch of inventions pop up that were almost self-reliant, right? Things like air conditioners or dishwashers or microwave ovens. You plug them in and they work. AI isn't like that. AI and any advanced programming capabilities are in the service of human beings, but they have to work symbiotically with human beings to be able to be as effective as they might be. And to be able to do that, to be able to better understand that, I tend to think of these sort of different aspects of AI. I think of what enables the AI evolution or AI revolution, if you please, is contingent on these four things. It's about augmentation, it's about humanization, it's about collaboration, and it's about individualization. And I want to spend the remainder of our brief time together talking to you about exactly that. The first aspect of AI that I think about in my lens as an AI psychologist is this notion of augmentation. With respect to augmentation, really what we're talking about is being able to enhance human capability, to create what I refer to as cognitive prosthetics. Right, very much like eyeglasses. AI can, used rightly, give us an ability to apprehend, to understand, to be able to attune ourselves to data in ways we might not otherwise ever be able to gain insights into the world, into the universe, to be able to put this information in service to us, and to draw from us, to be able to create new and better information. It's work that I've used to effectively, among other things, read minds at scale. Not as scary as it sounds, not nearly as impossible as it sounds, I assure you. It is predicated on the notion that people are far more predictable than you might think. They adhere to Newton's first law of thermodynamics, right? A body in motion will remain in motion unless it encounters some sort of an obstacle or some sort of a change. Humans are the same way. We behave consistently unless there's a massive change. And that those massive changes are very rare. And as a consequence, the behaviors tend to be largely predictable. This isn't just theory. This is work that I've used. Some of you will know that I supported the social media strategy for the 2012 Obama campaign. And I've worked as the chief data officer for Time Inc., the chief data scientist for Samsung. And I built many of the capabilities being used currently by the US government. They were all predicated on this notion that we could use data to gain insights into people, that we could augment people's capabilities, that we could transcend AI and also start thinking about IA, not just artificial intelligence, but intelligence augmentation. The next dimension is what I refer to as humanization. And humanization comes down to making computers, making these systems accessible and usable more effectively by people. We're doing some work currently in my shop that we call AI Joe. And AI Joe is an AI-enabled conversational chatbot that works with United States military veterans who are at risk of suicide. And it engages them in a very human and a very inhuman way. And so taking advantage of psychological insights, what we've done is we've managed to create a platform that it is at once perceived as being safer because it's not another human being you're talking to, it's just a robot or a bot. But on the other hand, people form such fast relationships with our bots that they tend to anthropomorphize them. They tend to treat them as if they're real people. And this isn't unique. We've been doing this with technology since Joseph Weizenbaum, a psychologist, invented the first chatbot, Eliza, back in, I think it was the late 50s, early 60s. Ever since then, we've been thinking about how do we take a human perspective, a psychological perspective to creating these capabilities. And we use this to form these relationships. It actually became the subject of a wonderful article in the New York Times and then a book by Judith Newman. She talked about how her autistic son managed to form an actual relationship with Siri, and Siri helped bring him out of his shell and help him learn to effectively become more human. The other dimension I tend to talk about is one of collaboration and the need to work integratively, collaboratively with our machines, with AI, with the technology, with the robots. And this has been a favorite of sci-fi since time immemorial. All of you know our friends, right? C-3PO, R2-D2, BB-8, the ones who we work with who work not just as machines, but as colleagues, as comrades, as people we can work collaboratively with. And if you prefer another franchise, exactly, we're seeing this rise. We're seeing not even just in the algorithmic sense, but even kinetically in the physical sense. We're seeing the rise of not just robots, but what are called cobots. This is Baxter. He's built by Rethink Robotics. He is a cobot. He works hand in hand with his human counterparts, and you can train him by you do work and he will emulate it. And if you move his manipulators, he'll do the same work, which, by the way, listen to me referring to him as he. I've already anthropomorphized and given him a gender. We're going to quickly see over the next couple of years the rise of these bots, these robots, these cobots, and they'll be replacing more and more human beings, particularly when you consider the very low threshold in price for these sorts of coworkers. What we're seeing in large, though, is this move toward what my colleagues and I refer to as symbiotic solutions, the synthesis between human and machine, what Garry Kasparov, the chess grandmaster, is referred to as centaurs. These partnerships that are able to form between people and machines to enhance the abilities of both. This also leads us to the next sort of dimension that I tend to talk about, which is one of individualization. There's a regrettable tendency when we talk about building these AI solutions so they can either interact with or even replace human beings as treating humans as if we're a monolithic entity, as if all humans are alike. And we all know that's not true. We know when we're building machines to work integratively with people, that people are very different. We can have some people and leaders who we work with who are brilliant and wise and have these extraordinary perspectives, and others that may not be quite as morally grounded or as gifted or as intelligent. Sorry, this is probably an unkind picture. Let's try that one. No, that isn't any better. Okay, we'll try that one. We tend to, when we build these systems, build them unmindful of these things. We tend to even ascribe moral failings to machines. We talk about things like algorithmic bias, and we talk about our concerns with taking decisions out of the hand of people. And we say we want these decisions left to human beings. Well, I always ask which human beings. Machines, the algorithms, have the ability to channel, to collect, to collate, to be able to integrate various perspectives and concepts and abilities into a single individual entity. We're going to start increasingly, I can guarantee you, to talk about collective intelligence and even collective wisdom and how we can use this more effectively. And we also need to think about this in the context of what impact these technologies will have on the future, particularly with respect to jobs. I know there's a lot of fear out there in the general public about the rise of the robots and how the robots will come to replace us and the machine will take the job that you had. And this is perpetuated in part by us, by academics, by practitioners, by those of us who are in this area. Most of you are familiar with the study by Oxford University that said 47% of jobs are at risk of automation. No lesser light than Warren Buffett came out recently, just a couple of years ago, and said the company of the future will have a machine, a man, and a dog. The man's job will be to feed the dog, and the dog's job will be to keep the man away from the machine. I don't know if that's true. I hope that isn't true, but we're starting to see moves in some of that direction, the increased automation of work. One of my favorite examples was by JP Morgan. Just a couple of years ago, about 2.5 years ago, I guess, JP Morgan came up with a new system they call COIN, which is an acronym for contract investigation. And essentially, this was meant to augment the work of the lawyers and loan officers that are in their employ, to go through documents, those tedious things. We have to make sure every I is dotted and every T is crossed. And their lawyers and their loan officers would go through, as you can imagine, millions and millions and millions of pages. And so they built this machine to see if it could help them. And it did. When they built COIN and they flipped the switch and they had it go live, in under 3 minutes, it was able to perform work far more accurately than would have taken the lawyers and loan officers of JP Morgan 360,000 hours. Now, the first reaction most people have when they hear that is, well, those lawyers and loan officers are all out of work now, aren't they? We can get a machine to do that more efficiently, more effectively, more productively, more accurately. Why do we need them anymore? That isn't what JP Morgan thought. What JP Morgan thought was, why not liberate them to do the work that only humans can do, that humans are uniquely qualified to do? That's been a focus of a lot of my own work. And in fact, I wrote an article about just this that appeared a few years ago on LinkedIn, and I titled it, "Robots Will Never Take This Job." And I wrote it as nothing so much as an homage to my wife. My wife has been a nurse, an intensive care unit nurse. This year marks 40 years of providing bedside care. I'm in awe of my wife. I think she's an extraordinary person. And I wrote this article in thinking about, will robots eventually be able to take her job? And I came to realize, perhaps. There is perhaps 80, maybe even 90% of my wife's job, of her daily work, that could be done by robots. They can administer medication. They can change the sheets. They can reapply dressings to wounds. But there are some things the robots cannot do and probably never will be able to do, at least not in the foreseeable centuries. They'll never have judgment. They'll never have humanity. They'll never have curiosity, caring, wisdom, or perspective. These are the things that my wife, that the human beings bring to work. That then becomes the secret. The secret to understanding how you can sort of future-proof your career, your organization, to be able to work more symbiotically with these robots is exactly that, is understanding what Hans Moravec, the futurist, talked about in his 1988, 1988 book he titled Mind Children. And in it, he posited a proposition that's since become known as Moravec's paradox. And he observed, isn't it interesting to think about the fact that the things that computers find simple to do, humans find inordinately difficult. But the things that people find simple, computers find difficult. Think about that. For a computer to give me the square root of 2,367,532 is nearly instantaneous. For most of you, it'll take a minute or two to be able to do that in your head. But if I show a computer a flower, it'll be lost, where a 2-year-old might be able to tell me if it's pretty or not. These things that we're able to do that they're not able to do, and vice versa, that complementarity, that becomes the key to the future. It is not man against machine, it's man and machine working collaboratively together. How does this matter to you, and how do you use this information to future-proof your career? Well, if you're a coder, if you're a non-coder, you should talk about what you can do to be able to work with and complement and work with these machines. But if you are a coder, you have to be aware that the low-code, no-code movement is gathering steam. We can already code most things in Python, which, let's face it, is the next best thing to just writing plain English sentences. Low-code, no-code is on the horizon, coming quickly. We're already able to build beautiful apps, just dragging and dropping. And there's going to be a time where those of us who write and speak zeros and ones are not going to be as needed as we are now. We are also seeing that not just the code is changing, and the ability to code is changing, but even the machines themselves. Remember, I talked about Samuel Butler's novel Erewhon, and I talked about this notion of self-replicating machines. I don't know if you've been following the news, but as of last year, we now have living robots that can actually reproduce themselves. We're coming to a time when we're not going to be needed just to code, just to build the machines. And so what do? How do you future-proof your career? What I'll suggest to you is you start thinking about taking a different perspective. You have to stand at the intersection of technology and psychology and start thinking about how these two interact, how understanding your users, how understanding the insights you can gain into human behavior, how augmenting the capabilities of the technology by insights into psychology can help your solutions better resonate and better solve the problems that you and your organizations face. When to do that, when to think about that? Well, I'll argue, my friends, that William Gibson was right when he said, the future, it's already here. It's just not evenly distributed. The time is now. The time is now to start thinking to yourself, how do we transcend basic technology to help implement these techniques, these solutions, these capabilities, so they're better able to resonate with the audiences that we are working with, both as users and as targets, and as people who are being served. Unfortunately, that's all the time I really have to spend with you today. I wish you well. I hope you will join me for a continuing the conversation. You can tune into our podcast. It's free to subscribe. We don't have commercials. It's just intended to be there as a conversation among colleagues, among us, so that we can chat. Thank you, everyone. Thanks for tuning in. That's all I have for today, and I'm going to turn it back to you, Justin. Thank you.
Thank you, JT, for an insightful session there, sharing with us the intersection between AI and psychology.